Have you ever been bored in maths class?
Have you ever felt like maths is just a bunch of equations and numbers?
Well, to your surprise, it's not.
We're going to show you that maths is more than just numbers.
Who doesn't love a roller coaster? A combination of speed, height, and energy are all needed to ensure a safe and exhilarating ride.
Without these essential forms of maths, the engineers, designers, and builders of roller coasters would not be able to complete their job.
We will be using this diagram to demonstrate how engineers use maths to determine whether or not a cart will be able to reach the highest point of a roller coaster. Engineers need to find the exact velocity a cart will need to travel at in order for it to have enough energy to reach the highest points of the coaster. As you can see, the height of point A is 5 meters, point B is not elevated so it has a height of 0, and the height of point C is 8 meters. The cart is traveling at 5 meters per second.
Before roller coaster engineers can begin to design roller coasters, they need to have two basic formulas in mind. The formula for kinetic energy determines the energy of an object in motion and is equal to half times mass times velocity squared. The formula for potential energy determines the energy stored in an object and is as a result of its height and is equal to mass times gravity times height.
Different points in a roller coaster, the rider's kinetic and potential energy changes. If the roller coaster is not going fast enough, the kinetic energy will not be enough to bring the cart up over a hill.
The law of conservation energy states that the total energy in point B is equal to the total energy in point A. The total energy in point A is equal to potential energy plus kinetic energy, and the total energy in point B is equal to potential energy plus kinetic energy. Therefore, the potential and kinetic energy in point A is equal to the potential and kinetic energy in point B.
Change this into the formulas to get the following. The m in each term cancels out. The equation is rearranged to make it solve for velocity at point B to get
Now that we know the velocity of point B, we need to determine if the cart is traveling fast enough to make it up to point C. All the kinetic energy in point B will at some point on the coaster become only potential energy.
So if all the energy was translated into potential energy, the kinetic energy in point B will be equal to the potential energy of the final position. Change this into a formula to get. The equation is rearranged to solve for h final to find the point where it stops on the coaster.
Notice that the height of the final position equals 6.25 meters, but the height of the hill is 8 meters. This means that the roller coaster was not going fast enough and will not be able to make it up the hill. The use of these formulas is crucial for engineers to make sure the roller coasters are continuous and do not stop.
We conducted an experiment with two batteries, 46 grams, and a small rock, 4 grams, falling down a slope to see if the weight of an object affects its speed. As you can see, the batteries took 13 milliseconds to fall to the end of the slope, while the rock took 16 milliseconds. The results were recorded 3 times and an average was calculated. The results show that the heavier object, the hamster, it will fall down a slope, meaning the more people on a roller coaster, the faster speed it will be going down the slope.